Hello, and welcome to the video portion for the RIBs lab of ME123. The RIB feature is a fairly specific tool, but it is often one of the best tools for the job. It can be imagined as a specialized version of the thin extrude. You can produce a sketch, and then the RIB feature will use the sketch to do an up to next extrude, using the sketch as a starting point, though it does have some quirks. Most often, the RIB feature is used to produce supporting struts within an object, and it's seen frequently in injection molded parts. Let's take a look at how it functions in the most basic circumstance. Here, I have a hollowed out cube, and I want to reinforce it by adding some internal structure. As with most features, we have to start by making our sketch. Remember, the RIB feature always uses the sketch as our starting condition, so we need to draw the sketch where we want the RIB to begin. The RIB sketch must always be drawn offset from the surface that we want the RIB to end on. In this case, I'm going to use this top surface of our cube here. We're going to start by creating a simple X. There we go. That ought to help stabilize it. Now, we can go over to Features, RIB, and look through the menu. Up at the top, we can choose how the feature uses our sketch. And in the preview, you can see that these buttons allow you to change the RIB to grow from one side of the sketch, the other, or equally from both sides. Continuing down, we've got our RIB thickness. I'm going to set mine to 2 units to match up with the wall thickness of our cube. Let's skip our directionality options for now and go straight down to draft. Like extrudes, draft allows you to set a taper to your RIB. RIBs used for injection molding often have a taper of about 2 to 3 degrees in order to make them easier to remove from the mold. Activating the draft does give us a new option higher up, where we can specify exactly where the prescribed thickness is being measured. With an active draft, you can set the thickness to 2 units at the interface, or where the point of the RIB joins the body, or 2 units wide at the sketch plane, which can be a handy option depending on your design intent. Well, now that we've made our decisions, let's see what it looks like. As advertised, the RIB acts as a thin extrude that goes all the way until it hits the bottom of our object, though it does have a lot more power than that. Let's mess with our sketch a little. RIB sketches have a unique property for this class in that they're the only sketches that are allowed to remain underdefined, though they do still have some rules. If we were to redraw parts of our sketch, we're allowed to have the endpoints underdefined, although the line itself must be fully defined. However, even with just the small amount of information, the RIB feature can take this sketch and expand the line until it hits the object and produce our completed feature. Of course, you're still allowed to fully define your RIB sketches, but you can leave the endpoints underdefined if fully defining them would prove difficult. This does introduce the question, though. What happens if the sketch entities go beyond the bounds of our object? If we have a sketch where the lines go outside of our object, or where there isn't anything to stop the endpoints, then we have a chance of getting the unbound RIB error. We can also mix closed and open contours in our RIB sketches. Here, I'm adding a circle to the center of the X that we drew earlier, which we do need to define the diameter of. Let's set it to 20. And when we exit our sketch, we can see that the RIB feature handles this perfectly. One thing to note is that sketch geometry also acts as a blocker for RIB sketches. If we were to go back into our sketch and remove the portions of the X that crossed inside of our circle, when we recreate the RIB, we can see that it leaves us with a hollow cylinder shape. Let's take a quick look at the last two options on the RIB menu, linear and natural. Whenever our sketch is purely straight lines and closed arcs, we can see that both of these options have the same result. However, the outcome does change whenever we have unclosed arcs or curves within our sketch. Here, I've modified the sketch to a half circle. If we go back and set our RIB to have the linear condition, then we can see that the RIB feature takes the endpoints of our arc and it draws tangent lines from them until they hit the surfaces. However, if we go back in and change it to the natural end condition, the RIB instead follows the same curvature, completing our circle. The option that you choose is going to be based on the outcome that you want, but both options are equally valid if you don't have any arcs. However, if you are not using the natural end condition, you do need to fully define the endpoints of your arcs, as the implied tangent edge will be underdefined if the arc endpoints are left floating. RIB works by extending the endpoints of your given sketch until they hit something, and it does this until it's fully blocked by your object. Let's see another example. Here, I have an hourglass shape that gets thinner and then expands back out. We can draw a simple sketch on this offset reference plane to produce a new RIB. Let's do a horizontal line that connects with our origin. Now, when we actually produce the RIB, our RIB follows the internal geometry as it changes, thinning as it gets to the midpoint, and then expanding back out at the interface to be wider than it was originally at the sketch surface. This could be something that is a real pain to pull off with the thin extrude. Okay, one last bit before we let you go. Rib directionality. It's important that you always make sure that the little gray arrow that you're given points towards the object. However, sometimes you may want the arrow to point along the sketch surface instead of orthogonal to it. This allows you to make protrusions that might be tricky to pull off otherwise. Let's look at an example on this barrel. On our right plane, we can draw a sketch that would look similar to what we would use to produce an extrude. However, we can leave it open along the edge where it would interface with the object. I personally tend to prefer leaving it so that the endpoints fully connect in with the object's geometry, but they can still technically be left unconnected if that proves difficult. The same definition rules apply that we listed earlier, so we need to make sure that all of our edges are properly located within the geometry, and that the endpoints of our arcs are properly defined. Now that we have our sketch properly defined, we can open up our rib feature, and let's check the direction. We want the little gray arrow to be pointing inwards, to where the material is supposed to be. This can be achieved through the usage of the extrusion direction options, or through the flip material side checkbox. Once everything's properly set, we can hit our little check mark up in the top left, and we can see that SolidWorks has produced our new shape without nearly as much hassle as would be needed to make it with a standard extrude. It even leaves the outside untouched. We can also use this trick to make geometry on the outside of our object. We just have to make sure that our rib sketch and the rib itself is fully bounded by your model. If I were to use this sketch to create a rib on the outside of our barrel, and then go to our feature and increase the thickness to the point where the model itself would no longer stop the rib, the feature throws an error message. However, by decreasing the rib size back down to a reasonable amount, we can see that the feature functions properly. Well, that about covers what I wanted to mention about ribs. The rib feature seems simple and unassuming, but it's one of SolidWorks' more versatile tools. I recommend experimenting with it to see what you can do. Thank you for your attention, have a good day, and we will see you again next time.